So we're going to be talking about batteries today. How many people are excited about batteries? Am I the only person that gets excited about it? No, I'm not. Okay, that's good. So we're going to be talking about as we electrify all of the vehicles around the world. Are we going to be making some of the same mistakes, repeating some of the same mistakes we did with fossil fuels? And can batteries be done in an ethical, sustainable way? So I kind of want to start off the conversation with Sandy first. Yes. Is ICE, internal combustion engine, better, or batteries for vehicles?
Okay, so let's talk. That's a very good question. Anyway, here's the deal. If you're using batteries, that means you've got an electric motor. If you have an ICE motor or engine, that means that you'll get 20% efficiency out of that engine. How many people knew that? And if you are very lucky, you will get, if you do things right, you may get somewhere around 180,000 miles out of your engine, okay? If you have an electric motor and a battery system, you'll probably get somewhere around 500,000 miles. So that's the first thing we should start at. And then let's start and talk a little bit more about one thing that people don't really take into account, and that's maintenance. So you have to change your oil, you have to buy gasoline, you have to flush your radiator periodically. Oh yeah, and you've got a transmission. There really isn't a transmission in an electric car, but you've got a transmission, and that transmission is going to have a whole bunch of things changed. And when you get all done, according to the EPA, and Automotive News, who just finally did their study, you'll pay, if you have an ICE engine rather than an electric motor and battery, you'll pay somewhere around $8,000 more after 5 years. So, with that information, I will let you make your own conclusions.
Okay, so we've established that electric is the way to go for technology. But that brings me over to Rebecca.
Okay.
Yeah. Let's go to the origins of batteries. What goes into it, and how do we source those materials today?
I mean, there's a lot of metals in ICE vehicles. There's even more in electric vehicles. There's 4 times more copper in an electric vehicle than a typical combustion vehicle. So yeah, we're going to need a lot more of those metals. We get a lot of them from BC, which is great. And the mining sector in BC is thriving, but geology doesn't respect boundaries, and if you're going to build a car in Europe or Canada, you're going to need to source materials from around the world to make that vehicle. So, and then getting them out of the ground is a whole panel on its own. But yeah, we've got a lot of places to dig and a lot of metals to find.
Can it be done in a sustainable way?
So, I have a fundamental issue with people calling mining sustainable. And I work in the mining industry, I should say that, I'm a geochemist. Because a mine, by definition, at the end of its life has no more materials in it, so that is not, fits under sustainable in that bracket. But there's a lot more that goes into mining than just getting the materials out of the ground. It's about water use, it's about land use, and all of those processes can be sustainable. You can ensure that the water in the region is still as it was before mining, providing you put the same practices in. The same with land use. We see a lot with design for closure and integrated closure in mine planning. It's a necessity these days for the right reasons. And that goes about how do we design the mine so it can be closed in an environmentally responsible way at the end. The sustainable part of that, I do believe batteries can be sustainable because that comes into the life cycle aspect of how do we recycle those metals and keep them in the system once we've got them out of the ground. So that's my 2 cents.
Unlike fossil fuels, when we burn them, it's gone.
I mean, there's a carbon cycle, but you're not going to get that back on your human lifespan.
So Ken, is the auto industry, do you think that is prepared for this switch to be able to manage all these batteries, everything like that?
that's a yes and no sort of question. So batteries have been around for a long time, and specifically in the repair industry and in with the recycling, they've been dealing with the smaller nickel metal hydride batteries from the older Priuses. The new batteries that are coming out are posing a lot more of a challenge for us. So in terms of, say, just under the recycling end of it, and when I say recycling, I'm referring specifically to where it goes into a metal facility and gets shredded up into a black mass. They have systems that are prepared for that. The real challenges, of course, is getting those batteries to those recycling facilities. There's only 3 or 4 major ones in around North America. And at the end of the day, like, somebody has to remove that battery, they have to transport that battery, and somebody has to pay for that. And it's very difficult right now for a lot of these recycling facilities to be able to turn profits. Oftentimes they're buying a black box, they don't know the chemical composition of that battery, they have different process lines, so there's a lot of challenges with that.
What are the biggest challenges to scaling up that recycling capacity and being able to do it?
Sorry, scaling in just what, in the direct recycling or in the whole?
For the recycling economy that's going to be building up around batteries, lithium-ion batteries. What is the biggest challenge?
So the biggest challenging right now is extending the life out of that battery into what we call value retention processes. And I think our guest from Moment Energy will have some good comments on that, so I won't steal his thunder. But we've heard a lot about what we call the closed loop or circular economy, and this is tying in the mining, the manufacturing in with that end of life, so we have a circle. But we can think within that, there are other little circles that we call value retention. So a battery that is, say, no longer of use for the vehicle can then, that is an output, it can be an input into a different product, right? And so with that, there are some real challenges with that. I know Moment Energy is doing some great work in with that. In with the repair, there are some real challenges in with, can we take a battery, can we repair it and put it back in the vehicle? That's our first challenge. Can we remanufacture? Or can we refurbish it? Do we take it out, give it a good balancing or a good polish, so to speak, and then extend that life for a few more years? So these are the real challenges that we're facing, and no one totally knows how that's all going to work.
Right. And thanks for teaming up to Ramesh, because I wanted to talk to you about that. What about second life of batteries?
Yeah, so when you get a battery from a vehicle and it's done that 500,000 miles, maybe hypothetically, or maybe a bit less depending on the manufacturer and the vehicle type, that's a problem we're running into right now. Recycling costs a minimum of $12 per kilowatt hour, and all the way up to, we've heard, $400 per kilowatt hour, depending on which recycler you're using. And a lot of the cheaper ones are not in business anymore, so we'll kind of see how that's going right now. But we can take the battery, and other companies in North America and Europe can do this as well, and give the battery a second life into a stationary storage system. But what Ken said is very much true. It's not as simple as removing a battery from a vehicle and plugging it into something. That can create a lot of risks with thermal risks as well as other risks. But we have to do pretty comprehensive checks into the batteries, and we have to apply some pretty complicated technology to make sure the batteries can remain safe through the rest of their useful life and etc. So it's a pretty involved process, but it's a way to take a product that would otherwise be a waste stream and put it into a value stream instead.
We can give a specific example about what Moment's doing, because I think that would help a lot of people to understand the context we're talking about.
Yeah. So Moment takes batteries from end-of-life manufacturers like Mercedes-Benz, Nissan, as well as almost any other automaker you can think of. And we take those batteries and we repurpose them into second life stationary storage systems. So one example of a project we're doing that's public is we are helping YVR deploy EV chargers to help support their charging infrastructure as they electrify their fleet. And these batteries are able to support the grid loads because right now BC Hydro is not able to run the power they need to all of these charging sites. So instead of spending millions of dollars and getting into the wait list for improving the connection, you can instead just install a battery and save some money there.
So Cindy, you see a lot of different kinds of batteries, kind of advances. What are you seeing more recently that's kind of catching your eye?
The thing that is really difficult for us. So we've had perhaps 100 electric vehicles that are thereabouts, maybe a little more, that we've torn apart. We pull out the batteries and we'll take certain sections. We have a look at who's got what chemistry and blah, blah. But then when we get all done, what do we do with them? Okay, so it'd be great if I could just, get Gamish to come to my house and take these buggers away. And then he could do something with them. But unfortunately, there's very, very little that if you're in my business, you can do with these things. You open yourself up to some absolutely horrific laws that are a problem right now. They need to be adjusted. So that's one thing. The second thing we're looking at is the battery packs that we pull out are not serviceable at all. I'm not sure if the guy's in the audience, but somebody came up to me yesterday and said, "Hey, I want to buy one of your 4680 batteries out of the Cybertruck you tore apart." I said, "No, I'm not doing it." And he said, "Well, why not?" "Yeah, you were selling them before for $600. "Yeah, and I lost $100 on each one, and that was before shipping. I'm not doing it anymore." "Well, I only need one. How much would you charge for it?" $1 million. Actually, should do the million. Anyways, it's really difficult to get them out of. That battery pack is 100% sealed. You can't get it anywhere. And we've seen that now with 2 or 3 different car companies that have decided that I want to turn this into a brick. That brick can be recycled by anybody that's in the recycling business. They take the whole pack, drop it in, chew it up, make black mass, and away they go. But I'm telling you what, taking out a single cell, impossible. Now that's what I'm seeing right now. And then in the future, I'm seeing something that's really cool. There's a company called Saku. Saku makes the magic battery. There's no metal in it. There's no copper. There's no aluminum. They don't need steel. You can drop it into a plastic case. It doesn't get hot. It doesn't catch on fire. They could stab it with a knife. So this, and all you get is what looks like black mass. They're calling it a polymer battery. But what's cool about it is if you think about the size of my hand, that's about the size of their package. But you have to think really small, like maybe 3 pieces of paper thick. You lay it down, you test it, and it's 3.5 volts. I take another one, drop it on top, push it down, and now it's 7 volts. On and on and on and on and on. And I have no connections. This is really the most amazing thing that I've seen so far. And from a battery recycling standpoint, or actually better yet, reuse, I'm all in. This is the best thing I've seen so far.
So when it comes to those giant brick batteries that you're talking about, do you think there needs to be some kind of industry collaboration around stuff like that to improve that?
Industry collaboration? I don't think you can use those words together. I don't think that's going to happen. We can't even figure out what plug we want to use for the cars. At the end of the day, I think that sooner or later the government is going to have to step up the plate, and they're going to say, you know what, enough's enough. This is what we're going to do from now on. And just like, I don't know if you're aware of it, but there was like about a zillion kind of electrical plugs when electricity was brand spanking new. And now we got 2 little flat things, they go into a hole and bingo. Look, the toaster works, right? So that's kind of like what we need now. We need to have the governments, at least the ones in North America, come together and say, this is the progress we've seen. This is where we see a standard going to. This is the standard that everybody likes. And then you've got something worthwhile.
What can policy do? What role can it play in federal government, local government? What can make that move in the right direction?
Yeah, that's a good question, because when it comes to government and regulation or intervention, it's a real balancing act. You want a certain amount for the industry to figure out on its own. Industry are the innovators, especially in the used or the aftermarket. These people are pioneers. They figure things out. They start with a lot of workarounds. The only problem with that is a lot of that is maybe going just to be purely profit driven. They might not take into other considerations like the environment. And what you end up with in 10, 15, or 20 years is not always the best outcome. So where government has to sort of step in a little bit is support the industry, especially to build in the local economies. So if we take the remanufacturing or the repair, ideally we want those things to be done locally here to build the jobs in the economy. What we are experiencing right now, for instance, is high export of salvage. So these are EVs, they've been into an accident, they are sold to auction. A very high percentage of them are not going into the local recycling and the local dealers to fix. They're exported outside of the province and outside of the country. So there are laws and regulations that we can do or to incentivize that salvage to stay within the province to build up our economies. That's certainly one thing. Another policy mechanism that they could do on the recycling end is through something called extended producer responsibility. That can be a good or bad, depending on the details. But as I mentioned, it's one thing to recycling them. You have a whole infrastructure to get those batteries to the recycling facility, and someone has to pay for it. So that may be some kind of an introduction of some sort of a levy or something like that onto the original purchase that can be used. So that's also another policy tool that governments can use.
I was going to say, like, but that variation in batteries, it doesn't stop at just the design of the battery. I work with car manufacturers and they can't even decide what they want in the battery. Like, do we want lithium? Do I want to buy, what form of lithium do I want to buy today? Kind of, it changes every 6 months. So, you know, that innovation, because the innovation in batteries is still happening, and it's happening in front of us in a, you know, open view, which normally with most things would happen behind closed doors, and people would bring you a perfect product at the end. You know, that's happening here and now, and so yeah, that impacts not just the kind of back end of the market and downstream, but also the upstream side of things when, you know, you're trying to just form something to get it out of the ground and get it to form to the battery manufacturer themselves.
To stay on that for a second, is there any policy changes or things that the mining industry needs to improve that process?
To extract...
To open up new mines faster, do it in a...
How much time you got? A typical mine can take anywhere from 10 to 30 years of discovery, and I think if we're talking about batteries and everything, the acceleration in electrification of EVs, we have to keep that in mind, is that the copper that I discover this year is probably not going to be in a car until like 2040. So if we want to accelerate that, we need investment in the mining industry. Innovation in discovery practices. All of the easy mines have been found. It's harder and harder to find a high-grade copper mine or a high-grade lithium mine. And then you've got the permitting side of things. That's my day job, is, you know, how do we make sure that the mine is designed and implemented and opened in a responsible fashion. We can't push for EVs and electrification of, you know, green energy without ensuring that we're still getting the minerals out of the ground in an environmentally responsible way. That's what's caused a lot of these problems to begin with. So that permitting process is very rigorous, particularly in BC, but it's there for a reason. So we as an industry and policymakers are trying to strike the balance between having a thorough process that protects the people, and the environment in those areas, whilst also trying to get this stuff to these guys as quickly as possible.
Why don't we open it up to the floor? If you have any questions, feel free to come up to one of the microphones. Is it not on? You might have to flip the switch.
It's like a little...
Yeah, I've heard the reference to black mass, and I'm wondering what makes up that black mass that they use to put into recycling. Is it the entire battery, or is it just a portion of the battery, and like what percentage would be actually recycled?
Well, black mass is basically, the reason it's black is because it's got carbon in it for one thing, but it has the lithium, all the ingredients of nickel and whatnot, all that stuff's basically in that mess. And what is done is there's two types of recyclers. One recycler will get rid of the copper, the aluminum, the steel, and any other impurities, and create black mass, and it can be either wet or dry. And then a second group will look at sorting out which chemicals are which, or not chemicals, but elements are needed. So they'll put them in different bottles, and now you buy that, and then you can reconfigure. Now, the reason that I'm wearing this jacket today is twofold. One, yesterday I was wearing a white shirt and carrying a coffee, and everybody knows the story, right? Oh, Sandy did it again. So the guys at Recyclable, who I've kind of interviewed a couple of times, they gave me this jacket to wear, and so I'm promoting them. And the other reason is strictly because, again, I'm into science. Recyclable takes black mass, and instead of breaking it down into its different elements, what it does is it says, well, what configuration do you want? And then it gives you back what you need to coat the anode and cathode. That I like a lot more than black. You tear the battery apart, you turn it into black mass, you turn the black mass into all the different elements. I like this one where you take the black mass and you say, okay, here's your new peanut butter, spread that on your anode and cathode. Didn't come out quite as, but anyways, that's
Don't eat the black mass.
Go ahead.
Sorry, that's on me. I've heard a lot about solid state batteries, and so I'm just wondering if there is any difference in the ethical, sustainable recyclability between what we have now. I think it's liquid batteries versus solid. We just thought maybe you could speak to where that's going. If we're someone who's just about to buy their first EV vehicle, should we wait till a solid, or is that going to be years ahead?
I definitely can answer this. Okay, so you know what? I've been everywhere, and I've talked to everybody's battery company, and there ain't a single solitary, well, let me rephrase that. I have not seen a solid state battery for real, period. They aren't out there. And when I talked to the guys over at QuantumScape, who said that they had it and whatnot, I went and looked at it, I watched through their process, and then I sat down with Jake Deep, the guy who was in charge, and he said, what did you think of our solid state batteries? And I said, they're not solid state. Let's start off right there. Now, some of you guys that are old, some of you people that are old, you know, it's not so much fun when you get older on it, and so you tell the truth and you don't care who you insult. So I can tell you right now, there is no solid state battery. The closest I've seen is that battery I just talked about at SACU, but that battery is, they're looking for funding. If there's a billionaire in the audience, go down and talk to them. I'll give you their names and you can go and invest in them. I think it's the wave of the future. But right now, it's still kind of an experiment. The best battery, as far as I'm concerned, that's in the market right now is the new dry cell, and I don't have one of those to take apart. The dry cell 4680 that's going into the next generation of Tesla. All the rest of the batteries are similar. Whether they're a pouch, whether they're prismatic, whether they're cylindrical, whether they're whatever, they're all pretty much the same at the end of the day. It's a little combination difference. By the way, the next thing that you're going to hear is something called the quotient, and 9.5 right now is what Tesla has, and nobody, and I don't even know how you make that work with so little cobalt, but nobody else has got anything like that. So That's it.
I was going to say, well, if you want to talk about the ethical side of batteries, which we're 25 minutes into this and we haven't actually touched on that at all, because that could also be a panel itself. If you're the battery composition of your EV, that all of those metals have come from different places. Cobalt is a prime example of something that comes from the DRC. There's a lot of artisanal mining and that's where you see the news about child labor and things like that. Whilst that's not the case all the time at all, and we need to stress that about DRC, it is known for that. So batteries that have less cobalt, have different metal compositions. That's why you're seeing lithium phosphate batteries coming back, partly because they're cheap, but also because you don't have those kind of potential ethical issues with some of the materials that go into these batteries. So, there is, if you want to be choosing your battery in your car, and you want to really deep dive, that's something that you can to consider. And there is a lot of work within the car industry. I remember having a chat with the head of sustainability in VW many years ago, and he reckoned by 2030, people will be buying their cars not just by the price tag, but by the blockchain code that comes with it that tells you exactly where everything came from in that car and gives you carbon capture and also an ethical kind of stamp. So maybe if you're going to buy your first car, it probably won't be out in time, but maybe consider it for your future ones.
Go ahead.
So I'm coming from a computer science background that goes back to when we used to store computer programs on cassette tapes. We're sort of in the same kind of situation now, going through the churn all the way to where we are today, where we have very modular computer systems, and it's going to evolve over time. And we've talked about the beginning of a battery and the end of a battery, but we haven't really talked about the middle space of the battery. And I think one of the ways to make our battery storage systems for EVs more intelligent, more ethical, is to push forward the idea that a battery needs to be able to go just a little further than your bladder can go. Because you're going to want to get out of the vehicle and take care of both ends of the business, recharging one thing and discharging the other. And as long as you can do that, who cares about the range of the vehicle? Really, seriously. The other thing is maintaining the battery in the middle. And I talked with Sandy briefly about that just before this get together. I really appreciated what he did tearing down an EV9 battery and commenting on the maintainability of the battery in the middle. And those are very important things. But charging the battery, discharging elsewhere, those things go, as long as those fit together, who cares how far the car goes?
I can jump in there. So I did a trip. I went from Detroit to Los Angeles to San Diego to Eugene, Oregon. And then I went from Eugene, Oregon over the Rockies, came down across the Great Plains, landed in, or drove down to Brownsville, where Elon Musk gave us an interview. That's as far south you can get in North America and still, or in the United States, and still be in continental United States and then back to Detroit. That's 13,800 kilometers, and we did it in 11 days. And brother, I can tell you, when we needed to charge, we needed to hit the restroom. I do not believe for a moment, not a second, that the idea of range anxiety is in the head of a marketing guy that probably works for, I don't know, Exxon or something. Yeah. This is all crap. Oh, and that was not a pun about, okay.
I think we have time for one quick question.
Yeah, I'm not sure if it's going to be that quick, but so I have, just to give you a background better, I have a Tesla Model S. I got it in 2015, so it has 9 years now, right? So the battery is the part where I'm preoccupied, right? Like I'm worried about it in terms of when it's gonna fail, right? It might take like 15 years or 20 years for it to fail, right? But I was looking in terms of, okay, what is gonna cost me to repair it, and what it would cost me to buy a new car now. And if you look at that, like I could sell my car for $33,000 or something like that, and spend $20,000 on a new car, new battery that has 8-year warranty, right? Where if I decide to keep it and see how long it takes, it's gonna be like $20,000 to repair. So, like, and they don't give you a 8-year warranty; they just give you like a 1-year warranty, right? So, what do you guys see in terms of like how to make the batteries more repairable and like economical to actually repair the car and extend the life of that car, right, for more years?
It's a heavy question. Does anybody want to take that real quick?
Sure, I can take a stab at it. We work at a pretty critical part of that value chain, for batteries, and what I can tell you honestly is, as Sir Sandy could echo, repairability is not improving right now. I think it's around 3 to 5 years away from when automakers are going to realize people are taking it into consideration when the competition grows. Ironically, the EV-only manufacturers like Rivian, Tesla, etc. are doing the best job on repairability, which I guess makes sense because they only sell EVs. But it's going to take a while for those prices to make sense of replacing the battery and getting everything into the value chain at the right time. There's not even many EV-only repair shops. I think I've seen like 3 in my time in North America, so not super common yet.
I will just add to that, it is becoming a very, very important issue. And the reason is that when you buy a used car out, it's not going to be shiny, and you can expect that things will go wrong. But this is a little different beast than just an engine or a transmission, where there is that repair infrastructure. You're right, if you're looking at a used EV 9 years out, it's a $20,000 car, and that battery fails to perform, it's one thing to put in a $5,000 battery, but if you're stuck with a $20,000 battery, that's making your choice very, very tough. Because you have to consider, look, if that vehicle were to get into an accident the next day, your insurance company is not going to give you the full value. They're going to give you the market value, right? And so until things really start to change, or until we can really get those repair infrastructure, that's going to really drag down the whole growth. It's not just about selling EVs, it's also about selling UVs and making this an economy for everyone.
Unfortunately, the rabbit right
Oh, I was just going to say, like, just think about that, but with the context of everything else that you happen to buy. It's not an issue that's just for batteries and EVs.
Yeah.
You need to buy a washing machine, it's cheaper to buy and you want to repair it. So that's not a car-only problem.
It's
We
perfect.
want to think close to time.
Well, give a hand to the fantastic panel.